Hi there, guys. In this video, I'm going to try and teach you a little bit about the atomic structure. This might be reminding you a bit about atomic structure, but we're going to talk about where the protons and neutrons are, a little bit of how the electrons are lined up, and hopefully give you enough information that you could start figuring out the mass of some particles or how many neutrons are there. I'll teach you a bit of a formula and see how it works out. Okay, so according to some of the theories of atoms that you've been looking at, we've learned now that the protons and the neutrons are all housed in the center of this thing called the nucleus. So they're all hanging out here in the center. That's just where the protons and the neutrons go. And the electrons, based on all the evidence we've seen, seem to be hovering out in energy levels in regions outside of the nucleus. And they're way farther away than you see in this picture. But they would be in orbit, so some electrons would hang out here, some electrons would hang out in an orbit above that or higher, and some would even be in a higher energy level. But I don't like the energy levels are not nearly as close as what you see here. The electrons would be way, way, way further away, like outside of the school further away for the first orbit. Very, very much further. Big empty space there. Okay, so we'll get this erased and out of the way. So if we were to look at, and so there's some basics you need to learn about the periodic table. If we think about an atom of carbon, so we're gonna, if you were to look on the periodic table and try and figure out where carbon is, you'll see that it's number 6 on the periodic table. So you look at it and it's got a little 6 up in the corner for its symbol. So it has its symbol, carbon, capital C. Its atomic number, that's the number in the top corner, we call it the atomic number, is 6. And the atomic number, this is an important part, the atomic number is always equal to the number of protons in the atom. So no matter what atom you're looking at, if it's carbon, the atomic number is 6, the number of protons is 6. If you were to look at another atom like sodium, and sodium, if you look at the periodic table, it's number 11. I'll give you a second to find it, number 11. So Na, sodium, it's number 11, which means it has 11 protons in its nucleus. Okay, that's always true. So let's watch what happens if we build this guy up. So if we put, for carbon, 6 protons in the nucleus. So there's 1, 2, 3, 4, 5, 6. So 6 carbons in there. Now you see this is updated. It says 6 protons hanging out there. And the atomic mass, according to this calculation, is now 6. Well, if I look at carbon, again, that number 6 in the periodic table, it says it has a mass of around 12. So it must have a bunch of these neutrons in there to make it heavier. So we'll put neutrons in. So 1, 2, 3, 4, 5, they're hiding underneath, and 6. If I put 6 neutrons, now my atomic mass is increased to 12. My protons are still 6, so it's still atomic number 6. It's still carbon. Carbon is the atomic number 6, and now it has the right mass of 12. So that means that this guy has 6 protons, 6 P's, and 6 N's, and the total of those equals 12. And that's the atomic mass. That's how much it weighs. Now, it turns out, right now, you're seeing an extra bit of information that we may learn later about the charge is 6. It turns out if it's going to have, for now, 6 protons, it also has 6 electrons. You'll see where I fill them in, but it really isn't important at this point. But we'll put 2 in this first ring, and then start putting in more here. 1, 2, that makes 4, 5, and we'll put another one down here, 6. So that would give a charge of 0. So, but the really important part I want us to focus on this is only the protons, the neutrons, and the atomic mass. That's where we're really, really focused on in a question like this. So, let's look at the table. So you should get a handout that looks like what you see here in front of you. And so it's got a carbon. So we look up C, so we can figure out the atomic number, and then we're going to see if we can figure out protons, neutrons. We're not going to worry about electrons, and thus the atomic mass. So we've just got those numbers to worry about. So on carbon, if I look, carbon was, we'll hide that notation for a minute. So we're going to move this right out of the way. Okay, I need some room to work. So we already saw that carbon was atomic number 6. And if it's atomic number 6, because that was the number at the top of the box, then its protons is 6. That's always true. Let's say instead of 6 neutrons, this table's telling us that this particular carbon has more neutrons. It might have 2 more, so it has 8. What would the atomic mass be? Question mark. Well, we saw the atomic mass, not the atomic number, but the atomic mass is equal to the number of protons plus neutrons. So your protons plus neutrons would be 6 plus 8 equals 14. So there should be an atomic mass of 14. So that's a particular carbon that has 14 as an atomic mass instead of 12. So now if we look, all we see is protons in the next row, protons of 7, and an atomic mass of 15. So we got to kind of work our way backwards using some of these formulas. Well, one thing to remember, protons is always the atomic number, not atomic mass, but the atomic number. So if you know that there are 7 protons, then you know it's element number 7 on the periodic table. Element number 7, you look for it in the table, and it has a big capital N in there. So it's nitrogen. Capital N is our symbol. If it's 7 protons, then the atomic number is 7. Now, how do we figure out the number of neutrons? Well, we know what the mass is. So I'm going to fill in from our formula. We know the mass. So if we had the mass number is protons plus neutrons. The mass is 15. The protons are 7. What's neutrons? Well, they have to be 8, because 7 plus 8 is 15. So this one has 8 neutrons. So let's take a look at the third line and see if we can figure it out. So if our atomic number is 25, atomic number is always number of protons. So 25 goes in protons. Protons and neutrons added together give us the atomic mass. So this atomic mass has to be 25 plus 28. So that gives us 53 as the mass. What element are we looking at? This says atomic number is 25. So the atomic number 25 happens to be manganese, Mn. So manganese, Mn. So you'll have your own table to try and figure out. Really, it's important to think you're gonna figure out the atomic mass or use the atomic mass. It's protons plus neutrons gives atomic mass. And we'll give some of those a try, and we'll see how you do with it. I'm sure.